Alright, this page is clipped. American Railway, signal session, Principles and Practices, Chapter 15, Block Signal Systems, published section, signal section is AAR, 59 East Van Buren Street, Chicago 5, Illinois. Published by the Association of American Railroads, Signal Section 59 East Van Buren Street, Chicago 5, Illinois. Copyrighted 1955 by the Association of American Railroads, Signal Section, printed in the United States of America. Alright. No attempt will be made in this chapter to indicate the chronological order of the sequence of events leading to the adoption of operation of trains under the block system. This is covered in Chapter 1, History of the Development of Railway Signaling. Suffice is to say that the blocking system means the maintaining a fixed minimum interval of space between two trains traveling in the same direction on the same track to prevent two trains approaching in the opposite direction from colliding on the same track. Prior adoption of the block system, predetermined interval of the time was used to avoid collisions. Time intervals are still in use of limited extent on the roads and part of the roads where trains follow one another only on long intervals. Alright, there are types of block signals. There are two general types of block signals systems used in American Railroad: the designated manual block signal system and the automatic block signal system. Included in this chapter is a method of governing and opposing the following movement of the trains by block signal, which is designated as traffic control system. Definition: the standard code of the Association of American Railroad defines the following terms that are used in block system. A block, a length of the track defined limits using which trains or engines is governed by a block signal, cab signal, or both. Block signal, a fixed signal at the entrance of a block governing trains and engines entering using the block. Fixed signal, a signal fixed in location, indication of condition after affecting the movement of a train or engine. Cab signal, a signal located by the engine compartment of the cabin indicating the condition affecting the movement of the train engines and used in conjunction with the interlocking signals and in conjunction with lieu or block signals. Home signal, a fixed signal, entrance of the route of block of the governing train's engines entering using the route block. Approach signal, a fixed signal used in connection with one or more signals to govern the approach through thereto. Manual block signal system. A block, a series of consecutive blocks governed by block signals operating manually upon the information of telegraph and telephone using other than means of communication. Alright, manual block system rules. In order that the student may have the better compensation and operation of the trains under block signal system, the rules of manual block system is as contained in the standard code as quoted as follows. 305. Block signals govern the use of the blocks, but unless otherwise provided, do not supersede superiority of the trains, and nor dispense the use of observance of other signals wherever they may be required. 306. When a block station is open with irregular hour and then open at irregular hours, trains must be notified when possible by the train order. 307. A train having entered in the block on other than a preceding indication must not accept preceding indications at any intermediate block with the close and with such a train entered block without receiving clearance from Form A. Alright. East and West Railroad Company clearance A. To C&E at blank and blank at. If blank orders are in the train, if no orders operate must write no on the spaces provided above. Number blank, and like 5 rows, 3 rows, and 5 numbers. When the form is used, then authority for the train passing the manual black signal and the stop signal condition block will be shown below. The block and the time the M is dispersed in operation. Manifold copies will be made for each conductor, engine man, or operator, with the later retaining copy to be used. 308. When the clearance form is used, information will be shown of the condition of the block of the clear occupied. If the block is occupied, we'll proceed with the prepared stop short train obstruction but not exceeding 15 miles per hour. Manual block system rules will be used only on territory specified on the timetable or special instructions. 311. Signal must be kept at the position displaying the most respective indication except for the display with immediate movement. 312. The appliance must be operated with carefully. Only those charged with the duty and any irregularity affecting the operation detected with signals must be displayed to give the most restrictive indication of the until repairs are made. 313. Operators must serve as far as practicable whatever the indication of the signals correspond with the position of the levers. 314. Operators must not make a permanent unauthorized repairs or alterations, additions to the apparatus. Any defects in the appliance must be promptly reported to the blank. 315. A block record must be kept at the block stations. See Figure 2. 317. On the track is demanded with the train block operators must examine the block record and blockhead vans and clear opposing train proceeding. Passenger train requests operated with the block station in advance with the block for number blank. If the proper train is admitted with the operating, the vans will reply OK block number blank. Operator requesting block will then display the proper signal indication. Operators must promptly enter on the block record the time block is given and received. A passenger train must not be admitted to the occupied block nor any train admitted to the block occupied by an opposing train or passenger train except under the flag protection. A train other than passenger train may be permitted with the flow of the train, other passenger train with the block and under permissive indication train order and clearance form A. 317. Optional. A single track admitted with the train and block with the operator must be engine block record with the block advance clearance for the opposing train preceding passenger train. Request operator at the block station in advance to block number blank. If proper train is to be admitted with the operation advance will apply OK block for number blank. Operator requesting block will then display proper signal indication. Operators must promptly enter the block record for the time block is given and received. The train must not be admitted to the block which is occupied by the opposing train, passenger train, except with provided in Rule 3033. The training order of the train permitted with the following other train other than the passenger into the block under the permissive indication of clearance form A. Note that Rule 317 is optional. Railroads that do not require blocking opposing should omit this rule. 318. One of the two or more of the tracks omit the train block. The operators must examine the block record to display proper signal indication. Passenger train must not be admitted to the occupied block nor any train submitted with the block occupied with the opposing train with the passenger train except under the flag protection. A train other than the passenger train may be permitted to flow the train other than passenger train into a block under the permissive indication of train order clearance form A. Permissive indication of the clearance form A. Note that Rule 318 optional. Railroad that does not use Rule 317 optional should omit one or two more tracks. 319. When a train enters the block, the operator must give the train number to the time the next block station advance. When two or more blocks are used in the same direction, operators must also specify for the track where the rear of the train has passed feet beyond the block signal. He must give the record of the train next block station and rear. This information must be entered on the block record. 320. Unless otherwise provided, the operators must not ask for the block until they have received part of the train from the next block signal in the rear. 321. Operators must, as far as practical, observe all the passing trains. Note whether they are complete in an order. Should the train without markers at the pass a block station, the operator must notify the operator at the next block station in each direction. Must not report the train clear of the block, nor clear the signal of the block in the rear until he is certain that the train is complete. 322. Should a train pass a block station with indication of the conditions and danger of the train on another track of the operation, immediately notify the operator at the next block station in advance. Each must display the stop indications to all the trains that may be affected. Must not permit any train to proceed until it is known that the track is not obstructed. 325. An operator informed of any obstruction in a block must be immediately notify the operator at the other end of the block. Each must display stop indications to all the trains that may be affected, so known as that the track is unobstructed. 326. When the train engineer clears the main track, the operator must know the clear block, and before giving the block of another movement displaying clear indication of the block, the operator must obtain control of the block before permitting the train or engine to re-enter the block. 327. To permit a train engine to enter the block of the valve on the main track to cross one of the main track to another, the operator must examine the block record. If the block is affected with the clear approaching train, he must provide a range of block protection before permission is given until the movement is complete and the block is clear. The trains will not be admitted to the block except as provided in Rule 289 or Clearance Form A. All crossover movements must be entered in the block record. 328. And when coupled with the train separated with the sky in Rule 364, the operator must regard each of the portion with the independent train. 329. When necessary to stop a train for which the other train stop indication has been displayed acceptably, the operator must give the handles in the addition to display the stop indication. 33. When and from any cause an operator is unable to communicate with the next block signal station in advance, he must stop all the trains approaching in that, and then it's cut off. So 335, block signals for the track apply with the only trains move within the current of the traffic on the track. Operators will use blank on the blocking trains moving against the current of the track. 336, operators are responsible for the care of the block station, lamps, and supplies unless otherwise provided with a signal apparatus. 337, lights in the block stations must be placed so that they cannot be seen from approaching trains. 339. If the stop indication is disregarded, the fact must be reported on the next block station in advance. Then to blank. To open the block station, the operator must notify the next block station in each direction record of the trains that are in extended block. When the trains which were extended block when the block station was open, which has been passed to his block station before it was open and clear the block in advance, he must repeat the record of the block station in the rear. 341. The block station must not be closed except upon authority of blank. 342. Unless otherwise provided, the block station must not be closed until the block is in each direction is clear of all the trains. To close a block station, the operator must notify the next block station in each direction when he receives the acknowledgement entering the block, and the record what with the time is received for each of the block station. The block signal must be secured in the clear position, and lights extinguished of the block wires when necessary. Circuits arranged with the work through the closed block station. 343. When a block station is open, irregular hours, operators use the hand signals in addition with block signals to give the required indications until all the trains have passed and which have been notified that the train order of the other block stations is open. 344. Operators must not permit unauthorized person to enter the block station. Engine or train crews block signals or track apply only with the train moving with the current or the track on the track. Blank will be used with block trains moving against the current of the traffic. 362. The train must not pass the stop indication without receiving a clearance form. A train must not proceed on the hand signals or as against block signals unless otherwise directed. When two or more of the trains have been coupled, some must move past the block station. They must be separated only at the block station of the operator notified. This is an arrangement of a manual block station. You see the switches, eastward main track. They pull off the track at different blocks until then there's the main track, and then the main track going this way, and the follow the main tracks. It pulls over on the side until the next block is clear. A train engine having passed beyond the limits of the block must not back into the blocks without permission of the operator. 370, where the obstruction between the block station notice when they given to the nearest operator when the train is stopped at the home of the block signal of the conductor or the engine man must not, when practical, immediately assertion the cause. 322, the conductor must report blank annually unusual detention of the block station. 373, The block station must not be considered as closed and exempt as provided in the timetable or blank description. As the name implies, a manual block signal system is a method of spacing the train in which the signals are operated manually without electrical or mechanical checks, subjects only to the rules. Manual block is flexible since the facilities provided can be increased or decreased if traffic warrants by shortening the length of the blocks. The protection afforded is against the head-on or rear-end collisions. Signal aspects and indications. Signal aspects and indications are explained in Chapter 2 with symbols, aspects, and indications. Two or more tracks. Figure 1 illustrates the two-track section of the block station. Second, spaced approximately 5 miles apart. These are another part of the operator on duty. Each of the block stations shown when necessary means of communication between the block system. Also means the station and the train dispatcher are located in some distant point. The means of the communication are generally telephones, telegraph. It's gradually being displaced. Each of the block stations there are generally two manually operated block signals. Approach signals to govern the approach of the trains to the block signals may be approved. When a train passes the block station A, the operator reports the first block station B. When a train passes block station A, the operator reports the fact to block station B. The operator at B receives the information, makes entry on the block sheet, then according to the Rule 318 displays the proper signal aspect. When the train enters the block and block station B, the operator B, according to the Rule 319, communicates the operator at the block station C to give him the train pass B. When the rear of the train is past the block signal at a specified distance, he must be given a record of the train at block station A. This information must also be entered into on the block sheet. The block sheet at the block station B would show the time the train passed the block station A, B, and C. Should it be necessary for the train to be held at block station B for any reason, this fact would also be recorded by arriving at departing time for the train being shown with this short explanation as the cause. If the train is not held at the block station, only one time is shown, which is entered in D or departed column, but a typical block sheet record from the block station B is shown in Figure 2. Alright, the A and B X and Y division. This is a block sheet. A typical block sheet has the station records, train movements. Block B, the station A, April 6, 1940. Signalman operator went on duty, went off duty. Leverman went on duty, went off duty. Weather, temperature, time. Transfer record at 19 trains, orders undelivered for the trains. Messages, overdue trains, noted, understood, and signed at blank and blank and blank. Eastward and westward, engines, time blocking, giving, time departed, time blocked, received, time arrived, track, time departed, time block cleared, remarks, train, engine, time block given, time departed, time track number, time block received, time arrived, time departed, time block cleared. Alright, they cut off this stuff, so it's really hard to read. But we'll start it after the passenger train to D. We'll start at the next paragraph. Various arrangements and effectively related to the method if followed should be the means of communication failed between any outlying points and the operator. One of the methods described is that from any cause the conductor of the engine man is unable to communicate with the operator, either by unusual means of communication or the use of commercial lines, should not cause to detain the train by it be known that it may be proceed through the block on rights on the timetable authority preceded by the flagman to the next point of communication reporting the superintendent. Single track. Figure 3 illustrates a section of the railroad where the trains are operated with both directions on the same track. It's usually necessary to have more sidings in the single track territory than in territory with two or more tracks. The frequency of the sidings is determined by the density of the track. Assuming that the two trains of the same class travel toward each other over their own block station A and D. If the train traveling from A to D is superior in direction of the train traveling from D to A, so that when it is necessary for the latter train to clear on the siding before the superior train is due to leave the block station at the siding. To operate the block station has been attained with the block and the block station being in accordance with Rule 17. The clear block except the display of movement from A to B. Short after the superior train block passes the block at station A, inferior train opposite directions approach the block station B. The operator in D obtains the block from operator C, but the inferior train passes block station D. With the clear block aspect, the superior train approaches block station B with this operator that has obtained the block from the block station C, and the train is given the clear block signal aspect B. The inferior train of the approaches block station C, with the operator must keep the both block signals in the stop position, and the train approaching from each direction. The inferior train approaching D stops before reaching the switch entrance and sliding to the siding. Each number of the train can recruit set the switch the movement to siding and the train and enter the siding. When the rear of the train is clear of the following point, the main track switch is restored to the normal position. The conductor reports that his train is clear of the main track and the switch is closed and locked. The operators on block station D and C make proper records on the block sheet, and operator C then requests block from the operator D, the superior train approaching block station B. After the permission is obtained by the operator, declares that C is clear of the block signal, allowing the superior train to proceed toward the block station D without stopping at C. On arriving at the other end of the siding, the conductor from the inferior train calls block station C for permission to proceed on the main track to block station B. As the superior train has passed the block, alright, this shows an arrangement of a single track with the sidings at block station C and B and A, and one goes through, like say you were headed main track is going both ways, so you were given the head of before train, say a train goes from D to C, and there's a superiority from B to C, but B to C, when train A from B, like train number 1 goes from B to C, and train D and C the train number 2 has to go pull on the siding of C because B is superiority until it passes C, and then it's allowed to go back. Alright, this is also cut off block operators so that they display the proper signal aspect. The inferior trains approach the block signal. In the case of a passenger train, the only one train is permitted between the block stations. No other train is permitted to occupy the block. A number of the railroad permanent freight trains will follow each other on the same direction in the same block. This term is called permissive blocking. On some of the railroads, only the train is permitted in the same block at the same time. Only some railroads, only one train is permitted in the same block at the same time. This is known as absolute blocking. So you have permissive blocking, where they're headed the same direction, same block. And on the absolute blocking, you have the same block, only one at a time permitted on the same block at the same time. Various arrangement of siding in effect with the different railroads. In some cases, one end of the siding of the block station. In other cases, maybe the midway between the block station. While still other cases, there may be 2 or more sidings between the block stations, where there are no operators and sidings and signals are not provided. The first train entering the block must report it's clear before the opposing train is admitted to the block. In some cases, we are known as lap siding, or used one which is shown with the block station B, figure 3 of the arrangement. It can be seen as the parallel movements can be made with these met and arranged without either train stopping when the traffic warrants. The side watches may be interlocked and provided with a spring switch. Alright, automatic block signal system rules. Automatic block signal system rules are contained in standard code as are quoted as follows. 505, block signals, cab signals, both governing the use of the blocks, but unless otherwise provided, do not supersede the superiority of trains, but dispense the use of observance of the other signals wherever they may be required. Engine or train crews, 508, unless otherwise provided with the block signal for the track applying only to the train engines moving with the current of the traffic on the track. 509, when train is stopped, the stop indication it may say until authorized proceeded when it's proceeded with a restricted speed. In the case of the failure, means of the communication may be preceded when preceded by a flagman. The next signal display preceding indication. When a train is stopped with the block signal with evident out of when a train is stopped by a block signal which is evidently out of order, unless otherwise provided, the fact must be reported to blank. 511. Both switches in crossover must be open before the train and engine starts. To make the crossover movement, the movement must be completed before each switch is restored to the normal position. 512. When switching indicators are used, the indications displayed do not relieve the engine man, train man from protecting the train as required by the rules. And the star means automatic block signal rules will be used only when the territory is specified on the timetable with special instructions. Where are we, actually? Down farther. This will not, 513, when a train engine has passed the signal permitting it's proceeded with delayed in the block, it proceed with restricted speed to the next signal unless otherwise protected. The entrance for the main track through a spring switch must be made under the provisions of Rule 513. Operating the switch by hand. 514, the train engine entering the block between the signals must be protected as required by the rules and must proceed at the restricted speed to the next signal advance. 515, a train engine having passed beyond the limits of the block must be not back into the block except under the protection prescribed in Rule 99 or blank. 516, should the cab signal or the fixed signal indication conflict with more, the restrictive indication will govern. 517, the cab signal indication does not supersede fixed signal indications except if the cab signal changes to more restrictive or more favorable indication after passing a fixed signal. 518, if after passing a fixed signal, the cab signal indication changes the restricted speed to a more favorable indication, the speed must not be increased until the train has run its length. Rules governing the movement of the trains in the same direction opposing the following movement of the train and block signals are also coded with the standard code. Rules governing movement of the trains in the same direction with block signals. 251, operation for the railroad and designated tracks so specified on the timetable. Trains will run in with reference to other trains in the same direction. Both block signals whose indication will supersede the superiority of the train. 253, the blank must be advised in advance that any condition that will delay the train, preventing it from making the usual speed, except as affecting the rule. 251, all block signal rules and operating rules may remain in force. Rules governing opposing following movements of the train. Block signals. Note the railroad operating under these rules must provide the proper signals to control the approach and movement of the trains. 261. On portion of the railroad on designated tracks specified on the timetable, the trains will be governed by the block signal whose indication will supersede the superiority of the train for opposing following movements on the same track. Description. In the description and explanation of operation of automatic block signals given in this chapter, it is to be understood that the circuits and special symbols and wiring normal case are not necessary specifications to represent. However, the typical circuits that are used on the railroad, certain modifications to meet the requirement standards on the individual railroad. The descriptions are given with the thought that they will enable the student to more readily understand the circuit of the similar nature, details on which they may somewhat different depending upon the practice of the individual railroad. The automatic block signal is arranged for a track signal in one or more of both directions. Generally, the track signal is in one direction. It is effect whether the two or more main tracks in service. If the track signal is in both directions, in effect where there are only one main track in service, the congested traffic areas. However, the more signal track is in service, one or more tracks may be signaled from train operations in both directions. Various schemes will describe detailed later. Direct current, alternating current is used for operating the automatic block signal. Direct current is generally obtained from the primary and secondary batteries for the operation of the track circuit and signals. The signals usually operate the first voltage range, 30 volts or less, while approximately 1 volt is applied to the track circuit. The alternating current is generally obtained from the transmission necessary powerhouses, substations, allied equipment distributed through the signal territory, transformers, and connected with the transmission line at the signal cut and station location to step the voltage down required for the operational signal and track circuit. In some installation, commercial power is obtained with the specified location. Direct current circuit is explained in Chapter 7. No coded direct current track circuits. Alternating current track circuits in Chapter 11. No uncoded alternating track current coded circuits. Chapter 25. Coded track circuits and Cephmore signals. Chapter 12. Cephmore signals and light signals. In Chapter 8. Light signals and signal lamps. Two more track signaling. If two or more of the track signal the track is in one direction, only one of each of the signal therefore theoretically be placed spaced on a uniform distance apart on the level of the tangent track. The practical, however, the impractical to obtain the desirable arrangement, the various conditions on the railroad will tend to vary more than less spacing between the signals, and the exact location of the signal is always selected with the care and the consideration being given to such a factor as the approach, view, the signal presence of the turnout, cross out over sidings or curve of the grades, hills, and bridges and tunnels, etc. Signaling one or two on two or more track railroads, generally two a block indication type. Although considerably, three block indication signals has been installed on the road's heavy traffic density where necessary to provide proper stopping distance. There are some installations for four block indications. Alright, this figure 4 shows the aspects of a displayed two blocks indication two tracks. West going that way and east going the bottom side, and the little signals for each of the indications of the set of the two block signals. Refer to chapter two, the AR signal and things. Alright, two block signal is so named. The reason for the clear aspect indicates that the two block advantage for the such signal occupied by the fixed signal and approach from the aspect indicates that only the block immediate with the advanced signal occupied by the train must be prepared to stop. If the next signal to stop and proceed aspect indicates that the block and the advance of the signal occupied that the train must stop and proceed at the restricted speed. Two block indication signals are spaced in the stopping distance apart for the minimum. The spacing is frequently increased where the traffic is light. Figure 4 illustrates the aspect displayed with the different signals when a block is occupied with a signal with the system. Two block signals on the section of the two track territory. The signal may be being normally clear. Figure 5 folds in the back chapter to illustrate the circuit used in one of the track of the two block indication color light signal installation employing the direct current neutral track circuit and polar line relay. Alright. Signal control the signal control circuit. The aspect displayed in each of the signal control with the polar line control relay HDR and the slowdown away repeater the relay HPR. The control signal 11 is followed with the positive battery B through the coils of relay 21 AER, wire 11 H3 through the contact of the track relay 21 TR, while the wire 11 HD2 from the front contact of repeating relay 21 HPR, wire 11 HD1 from the front contact track relay 11 TR, wire 11 HD through the coil of the relay 11 HDR with the wire N11 HD from the front of the contact of the track relay L11 20 TR and wire N11 HD1 through the front contact repeating relay 21 HPR with a negative battery C. The circuit will close the polar relay 11 HDR to be energized so the left polar contact controlling the clear position signal 11 will be closed. The train entering the block controlled by the signal 11 relay L11 HDR will be de-energized with the relay control through the first contact. The track relay 11 TR will cause the signal 11 to display the most restrictive aspect. It will also be noted that while the track relay 11 TR de-energizes the shunt provided through the back contacts, further ensure the polar relay 11 HDR remain de-energized along track circuit. The LT is unoccupied. When the rear of the end of the train is past the block protected with the signal 11 to the track relay 11 TR will energize polarized relay 11 HDR will also be energized both, but its polar contacts will be closed in opposite right side position from the figure shown in figure 5 with the control circuit. The polar relay 11 HDR is then follows the positive battery B through the coils of relay 21 AER wire 11 H3 to the front of the contact track relay 21 TR both, but these relays are de-energized with the circuit and will be to take the wire 11 HD2A through the back contact of the relay 21 HPR with the relay will also de-energize the N11 HD1 through the front of the contact track relay 11 TRY and advance the signals in terms of defining the territory beyond signals seen in the approaching train. Approaching signals in the rear signal is a term used defining the territory with signal indication conveyed. That's a double star. Signal lighting circuits. Circuits for the lights are of three aspects displayed by the signal 11 is the follows: positive B battery through the back contact will relay 11 AER, but the relay will be de-energized when the train passes the signal of the rear signal 11, the wire 11 DG2 from the front contact of the relay 11 HPR, wire 11 DG1 through the left polar contact relay 11 HER, and wire 11 DG to the lamp is in the signal which displays the green or clear aspect. The polar contact of the relay 11 HER is closed opposite position. Circuit will then be from wire 11 DG1 for the right polar contact relay 11 HER, wire 11 HG for the lamp of the signal will display the yellow and approach aspect relay 11 HPR, but the de-energized the circuit will then be from wire 11 DG2 through the back contact relay 11 HPR with the wire 11 RG for the lamp in the signal, which will display the red stop and proceed as aspect. The return circuit from each signal is in wire C, the negative battery. It will be noted that signal 11 is approach light. This signal is normally dark. The track enters the block in the rear of the signal 11. The track relay of the signal will be de-energized. Will cause the relay 11A ER. It will be de-energized, similar to de-energization of relay 21 AER, it's completing the light circuit through the back contact light proper lamp. The signal 11, depending on the position of the contacts, relays 11 HPR and 11 HDR. The HPR relay slows the drop away so that the pole changing on the relay HDR occurs through the will momentary change the aspects during the operation. Some railroads desire a single rear of the train should remain lighted as long as the block is occupied. In the case, there would be slight change in the wiring indicated with note 1, figure 5. As previously stated, there are various modifications of control circuits from the automatic block signals, such as using retained neutral line polar line relays based on relays installed in the ordinary polar relay shown in figure 5. By a careful study of figure 5, any modification should readily be understood. Frequently, due to traffic conditions, automatic block signal spacing is such that it is necessary to have more than one track circuit between the signals, and figure 6 illustrates the illustration using relayed cut section, neutral, and line relay. And noted that the two-track section is designated with the A11T and B11T. The track section A11T is controlled through the track relay. B11T is followed with the positive track battery on the wire A11TB. The variable resistance of wire A11TB1 through the front contact track relay B11TR and wire A11TB2 for the positive rail track circuit A11T. The negative railway track circuit A11T and wire A11TN to negative battery, negative track battery. Be noted that when the track battery B11TR is de-energized, the shunt of the track circuit A11T is provided with the wire A11TB through the back contact track relay B11TR with the wire A11TN. The further insurance that the track relay A11TR will remain de-energized as long as the track relay B11TR is de-energized. If more than one relay cut section is required, additional ones will be arranged. Similar to the manner that just described, the control circuit for the other relay light circuits are quite similar to those described in figure 5. Should be easily traced out, and the circuit will be then noted to provide an advanced approach to light signal section. The star stands for folded sheet in the back chapter. Alright, through the contact relay 11TR with the coil signal 11 through the front contact relay 11TR with an N9LHEG from the front contact of the relay 21 HDGPR with the wire C to the negative battery. When the circuit of the signal 11 will be energized through the movement of the element will the position display with the green or clear aspect. This N aspect will display the signal 21 display on the green, yellow, and aspect, which will keep the relay 21 HDGPR with the energized flow positive battery through the contact G with the signal 21 through the coils of the relay 21 HDGPR with the wire C to negative of the battery. If the yellow aspect displays the circuit with then positive battery to contact R and Y, the contact Y would be closed through the coils of the relay A21 HDGPR wired C negative batteries. Signal 21 be displayed the red aspect 21 HDGPR would be de-energized. This is the term would reverse the flow of the current through the signal 11 as follows: the positive battery through the back of the contact relay 21 HDGPR, the wire N11 HDG through the front contact with the relay 11TR through the coil signal 11, and through the front contact relay 11TR with the wire 11HEG, through the back contact relay 21HEDGPR with the wire C to the negative battery. This reversal current of the signal through signal 11 would be moved to the yellow rondelle signal mechanism in front of the lamp as we yellow and its approach to aspect would be displayed. Such track relay 11TR with the de-energized signal 11 would be de-energized. The movable element would be placed in the red rondelle in front of the lamp. The gravity either in red or stop proceed aspect would be displayed through the back contact relay 11AER wire 11E to the filament of the lamp of the wire C to the negative battery. The figures in the circuit in figure 7 indicates the signal 11 is normally dark lights up when the head end of the train passes the signal in the rear signal 11. Should the advanced light signal is not required, with the wire A shown dotted with would be added in accordance with note 1 in figure 7. Alternating current tracking control circuit. There are a number of the installations where the alternating current track circuits are used in figure 8. Illustrates the circuit used with the 2-block indication color and light signal installation on the 2-track electrical road using alternating propulsion. Installation employs the 2-element 2-position central figure track relays, 2-element of the 3-position, single element of the 2-position line relays, the 110-volt buses at all locations energized with the solar connected for the same source that they would be on the same simultaneously polarity. The local element of the 2-element relays connected with the direct BX 1110 and 110 CX 110 buses. The line element of the single control relay, or HDR, is only energized when the track circuit is advanced with the single unoccupied. The instantaneous polarity of the line element and the local element is the same, and when the signal connection control repeating relay, HPR, at the signal and advance with the de-energized opposite relay, HPR, at the signal and advance with the de-energized. The circuit for the line relay 58 HDR as follows: the secondary transformer primary, which is connected with directly to BX 110 and BX 110. Full star means fold the sheet on the back chapter. All right, then it's covered up. I'm like, it's whoever scanned these got them wrong. The filament at each lamp is connected directly to the secondary transformer located in the single unit of the primary. These trampers are connected with the relay contacts BX1110 and CX110 buses. When relay HPR de-energizes the transformer, the red lamp will be energized when the train approaches the signal, which relay HPR is energized with the transformer. The yellow lamp, the green lamp will be energized depending on the positive position of the relay HPR. In order to have the marker lamp burning whenever any other lamp is burning, the transformer is at the marker lamp is energized whenever the relay HPR is de-energized when the train is approaching the signal. The circuit of the red lamp signal 56 as follows: BX1110 BX110 through the back of the contact relays 56 HBR with the back of the contact relay 58 TR, wire 56 DG2 through the back of the contact relay 56 HBR, wire 56 RG for the transformer at the red lamp of the CX110 with the circuit of the yellow green lamps. The signal 56 is as follows: BX110 through the back contact relay 58 TR 56 DG2 through the from the front contact relay 56 HBR, while the wire 56 DG1, either the normal polar contact relay 56 HGR for the wire 56 DG with the transformer of the green lamp to CX110 through the reverse polar contact of the relay, the 56 HGR of the 56 HG, to transform the yellow lamp of the CX110, the circuit of the marker, the lamp signal 56 as follows: BX110 through the back contact relay 58 20 TR, or through the back contact relay 56 HPR 56 wire 56 MG, the transformer at the mark of the lamp CX110. Figures are different location circuits are protect. The apparatus is shown in figure 8. Alright, 3-block indication signal. 3-block indication signal is deployed when the desire to increase the track capacity. This permits closure spacing the trains moving under the procedure signals would be possible with 2-block indication signals. This will be recalled with the 2-block indication signals. The signals are located with the stopping distance part of the minimum to the permit the train is to stop, and then stop and proceed signals when moving the authorized speed with the approaching signal. An illustration of 3-block indication signal. Each of the fixed signal usually displayed proceed with advanced approach, medium approach, approach, stop, and proceed aspects depending upon the block condition. Generally, the fixed signal of the two operating units of the 1-3 position until it move above the 2 or 3 position units. 3 block indication system is named for the reason for the proceed. The aspect displayed in the unit to at least 3 blocks is an advanced signal unoccupied. An advanced approach of the approach medium aspect contain and not be displayed until at least 2 blocks in advance. Then it skips a half a paragraph. When a signal is shorter than the distance required to reduce the maximum speed, the advanced approach indicating the rule 282, the proceeding to stop the signal. Second signal is also installed with the approach of the medium indication of rule 282, the high maximum authorized speed. This distance is usually 75 to 80% of the stopping distance. Figure 9 illustrates the control circuits for the signal of 3 block indication system using local control or back track and retain neutral polarized line relay signals between the searchlight type. Signal control circuits. The proceed with the control circuit of the signal 22 that is followed with the positive battery B through the front of contact with the direct relay 12 TR with the front of the contact G with the single 12 to A with from the coil of the relay 12 EAR. AER through the contact of the relay 12 DGPR with the wire 22D from the front of the contact 22 TR through the coil of the relay 22 DR with the wire N22D through the front of the contact relay 12 DGPR through the front of the contact relay 12TR with the wire C negative battery. This will cause signal 22A to be energized with the position display with the green or proceed aspect. Signal 22 has followed the positive battery B through the front of the contact relay 22R through the normal power from the front of the contact relay 22DR through the coil of the signal 22A through the front of the normal polar contact relay 22DR through the front of the contact relay 22TR wire C negative battery. This should signal 12 will display an approach signal. The signal 22 will display an approach medium as aspect. Follows the positive B battery from the front of the contact relay 12 TR through the contact Y signal 12A through the coils of relay 12 AER through the contact relay 12 DGPR, but the relay would be de-energized on my account with the signal 12 displaying an approach this aspect with the wire NTT and 922. N22D with the coil of the relay 22DR through the front of the contact relay 22DR, wire 22D from the back of the contact relay 12 DGPR from the front of the contact relay 12TR with the wire C negative battery. This circuit would cause the normal polar contacts on relay 22DR to open and close with the reverse polar contacts with the turn reverse the flow of the current through the coils and signal 22A as well as energize the signal 22B. The circuit displays the approach of medium aspect. Signal 22 would then be follows the positive battery from the contact relay 20TR through the reverse polar front contact relays the 22DR through the coils of the 22A through the front and reverse polar contacts the 22DR from the front contact to relay 22TR wire C negative battery. This would cause signal 22A to be energized with the position display of the yellow and light, and the use at the same time would be energized with signal 22B the display of the green light on the bottom of the unit. Signal 22 follows the positive B battery from the contact relay 22R to 22TR through the contacts Y and RY with the single 22A through the front of the reverse polarity contacts of the folded sheet in the back of the paper. Alright, should the signal 12 display the top of the proceed aspect, signal 22 would then display the approach aspect that follows the relay 12TR would de-energize the approach of the 22DR would also de-energize the circuit the yellow with the approach of the signal aspect. Signal 22 would positive battery B from the contact relay 22TR with the back contact relay 22DR through the coils of the signal 22A through the back contact relay 22DR from the contact relay 22TR with the wired and C negative battery. This would cause the current to flow from the coil of the signal 22 the direction using yellow and approach the aspect of the displayed. A train in the block advance with the signal 22 would de-energize the relay 22TR with the signal 22 could not de-energize the red or stop proceed aspect would be display. The purpose of the retaining neutral feature of the relay 22DR is to keep the front of the contacts closed from polar contacts and moving in one position to the other. Alright, two-way blocking indication signal with one of the block overlapping. The system shown in Figure 10 with the fixed signal operated with the 3D position display, proceed, approach, stop, and proceed aspects. The stop and proceed aspects displayed on each signal, however, the control through the two blocks instead of one. System of the type that's generally used on the subway of elevated railway lines where the trains are operated with a high speed at frequent levels, and automatic train stop devices generally use the signal system. Figure 11 illustrates the circuit with a normal clear color light signal illustration subway where the trains are operated with a direct current through the signal system, flowing alternating current track with the direct current neutral control circuits. The track circuit is a single relay alternating current through the two element relays, one reacting with the common rail with the return of the direct current for the propulsion for the alternating current track circuit. When the train occupying the block proceeds signal 2, then will be noted with the signal 2 and 4 displaying stop and proceed aspect, signal 6 approach and aspect, and signal 8 proceed aspect. And the system signals are spaced braking distance apart, but the maximum speed for the train is always protected by the automatic train stop at the stop and proceed signal at one block in the rear of the following train should pass the signal indication stop and proceed. Local element circuits. Local element circuits are all track relays energized by the continuously BX55 and CX55 being connected directly to the coil terminals. Automatic train stop control circuits. Automatic train stop assumes the non-tripping position of two track circuits advance and are occupied when the train enters the first of these tracks. Figure 10 shows the action displayed of the two block signal and system two track one block overlap. It shows the proceed stops. Like right here, these have like east and west and different. These are the same signals. Then two signals. These are all like the whole eastward westward track is the same signal while the other one stops in the it's a one block overlap loop. Signal control relay circuits. The signal control relay circuits (HSR) will control the approach of indicating the circuit of the signal energized for the following passage of the train with the contact of the train stop at the trip position. That the signal of the front contact is also associated with the track relay and the new track relay in advance for the both of the circuits unoccupied is held energized and over its own with the contact is stop at the move of the non-tripping position. This is called the cycle check, checking that the stop has gone of the tripping position back of the train. The signal control relay DR, which controls the preceding indication energized for over the signal control relay HSR relay has advanced energized for the stop and advance for the non-tripping position. The guards against the preceding indication for the next stop advanced tripping positions. The circuit and the signal control relays are at signal 8 shows follows the positive battery B16 through the contact of the track relay 6DR and 8TR through a contact stop at the DV and the tripping position over the contact with the 8SHR after it has picked up and stopped clear through the coils of the 8HSR negative battery C16 with the positive battery B16 through the contact of 6HSR with the contact stop at 6V with the non-tripping position through the coil of the AD8DR with the negative battery C16. Signal lighting circuits. When the signal lighting circuit of the HSR is de-energized when the train stops at the tripping position, the red light will burn relay HSR, energized relay DR with the de-energized yellow light will be burning. When the both signal control of the relays HSR and DR energized, the green light will burn. The signal with the red or stop at any time of the stop at the tripping position check against the clear signal with the stop that fails to go non-tripping position at the reason. Lighting circuits or signals are as follows: the BX through the back contact of the relay. 4SHR with the contact stop 4V with the tripping position for the filament of the lamp. Red signal is CX55 BX55 from the front contact 4SHR with the contact 4V with the non-tripping position. Back contact relay 4DR with the filament lamp with the yellow signal CX55 and BX55 from the front contact relay 4SHR with the contact stopping 4 volts with the non-tripping position. The contact with the relay at 4D with the filament lamp with the green signal X55. Explained in detail, chapter 25 of the code of tracks. The figure 11 shows the illustrated installation code of the track circuit with the direct code of the control for the signal reverse from the approaching light over the other approaching controls. There's also a cut section between the signal and the code generally used for the track circuit. There are 75 per minute to cover the approach aspect display, with the 120 from the approach medium when used for the 180 preceding aspect number code would cover the stop and proceed aspect displayed. The circuit of the figure 12 would cause the signal 22 to display the proceed aspect of the valve. The signal 12 displayed the proceed aspect of the 180 code of the control relay. The CT at the signal would be then operating receiving the positive battery B from the contact relay 12 HR with the coil of the relay. The CT 180 for the wire C negative battery that would cause the relay 12 CT PR with the operator of the 180 code with the receiving the positive battery B through the contact CT 180 from the front contact relays 12 HR and 12 HGG PR through the coil of the relay CT's 12 CTPR with the wire C negative battery current track circuit B22 for the T and the positive side of the track battery through the front of the contact relay 12 CTPR with the positive rail with the negative rail with the negative side of the track battery that would place the 180 code with the track circuit BT22 with the cause of B22TR with the cut section operating with the code and serving the energizing pole as a rail from the back contact or relay B22TPAR through the coils of B22TR with the negative rail the relay of the B22TR operating at 180 code. The track circuit A22 will receive a 180 code with the positive side of the track batteries through the front contact of B22TR with the positive rail from the negative rail with the negative side of the track battery. Relay of the A22TR will respond to the 180 code track circuit. A22T will receive the current from the positive rail through the back of the contact relay. A22PAR through the coils of the relay. A22TR with the negative rail. A22TR would be operated with the 180 code. This would supply the current with the decoding transformer to 22 DT for the positive battery B through the front contact of the relay. A22TR with the tap of the primary winding of the 22 DT from the center of the negative battery C. A22TR would de-energize the circuit, would then form from the positive battery B from the back of the contact A22TR to the lower tap of the primary winding of the 22 DT with the center tap of the negative battery C. The circuit would energize the primary coil of 22 decoding the transformer, the pulsating direct current which would produce an inductive and effective secondary coil of the 22 DT. The relay of the 22 HR would then be energized from the center of the tap second coil 22 DT through the coil of the relay 22 HR relay. A22TR energized from the front of the contact A22TR with the lower half of the secondary coil 22D2 and A22TR with de-energized from the back of the contact upper secondary half coil 22D2, which relay the 22HR energized relay 22DR would then be energized circuit upper binding post of the primary coil with the 22D2 from the descending decoding unit 100DU through the front contact relay 22HR with the bottom binding of the primary coil 22DR. The operating decoding units is covered in chapter 25, decoding track circuits. The preceding aspect signal 22 would be displayed in the positive battery B for the front of the contact relays 22HR and 22DR with a single contact 22 from the contact relay 22DR and 22HR of the negative battery C. This would stars from the folded sheet in the back of the paper. Alright, stars would, and then it cuts a paragraph. Like, I don't see the point of it dropping in the middle, and this is almost useless as a reading because of that. Any remaining secret in figure 12 should remain readily traced out in accordance with the explanation given in the preceding description of the various other arrangements, circuits, and apparatus service on the individual railroad's principal application in such manner or the time described in figure 12, but the student should experience little difficulty in tracing various circuits. And I'm gonna. Alright, your single track system. A single track train movement is both direction signals are arranged for the permit of following the movements as well as opposing movements. For the opposing movements, a single control circuit it must be arranged so that they prevent the display of the signal aspect that would permit the opposing train to enter the same block at the same time. The three general schemes in effect with the controlling signal on a single track, the furthest known as the overlapping, the second absolute permissive, and the third of trafficking locking. Later scheme that permits the movement of the trains and signal indication without regard regard of the class direction of the right under the scheme. Standard Code Rules 261, 263, and 264 are in effect. Through the first two schemes require the superiority of the train must be observed on the track signal. Movement in both directions the train shall cause the one or more opposing signals immediate with the head of the display at an aspect requiring the stop. On such track, signals should arrange with the control and the opposing train signal passing, displaying preceding aspects. Next signal advance to each of the such signal, then display each of the an aspect requiring the stop. The distance between the opposing signals requiring the stop that shall be not less than the aggregated stop distance between movements in each direction. When such opposing signals are stopped in distance but apart with the movements in one direction, the signal arranged with the display restrictive aspects shall be provided by the approach of at least one signal, where such opposing signals are spaced less than stop distance of moving apart movements in one direction. Signals arranged with the display restrictive aspects should be provided with the approach of both signals. The overlap system. The overlap system provides the control of the signals extended in the territory with another signal and signals governing. Figure 13 illustrates the controls of an overlap system with the leaving signals and siding located in the clearance point. In some of these cases, Alright, figure 12, 13 shows a diagram showing track limits of the single control circuit, signal track overlaps. Alright, cause signals to eastward train passing signals, alright, detailed circuits of the overlap system are not described. They are quite similar to those used in absolute positive block system, which are described later, which is now superseding the overlap system. And we're gonna pause it right there. Got 14 pages to read. Alright, absolute permissive block. In an absolute permissive block, the block is from siding to siding. The opposing movements of the signal governing the entrance of the blocking indication stop when the block is occupied by opposing train. The following movements of the section between the siding is divided into two or more blocks. Train movements in the blocks, except the first one, are governed by the intermediate signals, usually the display stop, and then proceed at the most restrictive indications. Figure 14 illustrates the controls of absolute permissive block. In this system, signal blocking of the opposing train movement to the siding with a head block signal located just ahead of the switch. These signals are absolute stop signals. The following train movements in this section between the sidings and divided into three blocks. The train movements in these blocks, except for the first one of the direction, are governed in intermediate signals. The most restrictive indication for which the stop proceeds it will be recalled for the description overlapping scheme with the figure 13. Should two trains move toward each other of the siding A and B with the pass signals 5 and 12 simultaneously for each of the signal indicating proceed, it would not cause all opposing signals to assume that there must be restrictive aspects before absolute permissive scheme. All intermediate signals would display their most restrictive aspects. The signals 7 and 10 would display stop and proceed. The approaching trains thereby providing ample aggregated stopping distance. Figure 15 illustrates the control circuits for the track section between the siding of the figure A and B, but the opposing train would then be held with the siding of the stop signal. Following the train movements in the same direction will, of course, receive the signal depending on the location of the train in its following. The absolute permissive scheme of the signaling is to be understood, but the trains must also observe the class direction and right, and similar to those overlapping schemes. The circuit shown in Figure 15 indicate that no train approaching in either direction. All signals indicating proceed assume no westward train approaching signal 1 and signal 2 will be displayed in stop proceed due to the approaching train occupying the block controlled by signal 2 with. Alright, view, rotate, clockwise. Figure 14 shows a diagram of tracks, limiting signal control, absolute permissive automatic block. You see the bigger permissive automatic block with 3 or 4 different sidings coming in from just to make sure, I think a couple pages were skipped on this. Like figure 15 should be there. Alright, the circuit arrangement and the installation using the HD relays, the neutral slow release HP relays, the third wire three-wire HD control between the signal of the control circuit with the signal 22 the follows the everything normal positive of the battery BS and taken with over the front contact relay 12 HPR with the back contact stick with the relay 11 SR, front contact track relay 11 TR, wire 22 HD with the front contact track relay TR 22 TR through the coils of relay 22 HDR, front contact relay 22 TR with the wire N9 N11 22 HD, front contact relays 11 TR and the 12 HPR with the negative battery CF with the current flowing through the coils with the relay 22 HDR in the direction it will close the left-hand polar contact with the relay to close completely the circuit from the positive battery B from the front contact relay 22 HPR with the left polar contact relay 22 HDR wire 22 DG for the lamp with the green preceding aspect unit wire EN for through the back of the contact relay 21 HPR with the wire C negative battery. An eastward train approaching 22 signal 22 would have the signal control relay 22 21 HPR de-energized which permits the approaching signal of the 22 signal 22 as soon as the train occupies the track control in signal 21. When a train passes through signal 22, it will de-energize the track relay 22 will de-energize the signal control 22 HDR, which will in turn extinguish the free green light and light the red unit receiving the positive battery through the back of the contact relay 22 HPR, wire 22 RG with the red unit with the wiring EN with the back contact with the relay 21 HPR and 22 HPR wire C with negative battery. With the relay 22 HPR de-energized, it will continue to keep the red unit displayed and stop proceeding as long as it can block is occupied. As the train passing through signal 12, the stick relay 12 SR will energize the receiving the positive battery BM through the back contacts relays 11 SR and 11 TR with the front contact relays for the relay 12 HDR through the coils of the relay 12 SR with the wire CM with the negative battery stick circuit will keep the relay 12S energized through the back contact relays 11 SR and 11 TR through the front contact relay 12 SR, even though the coils of the relay to the negative battery CN, the rear end of the train passes signal 12, relays 12 SR will still remain energized with a certain tapping of the between the railways 11 SR and 11 TR through the back of the contact relay 12 HDR through the front of the contact relay 12 SR through the coils of the relay negative battery CN under the condition signals 22 with the display of the approach aspect and approaching the train is controlling the 22 HDR being energized with the positive battery BS from the front contact relay 12 SR, back contact relay 12 HPR with the contact from relay to 11 TR with the wire N11 22 HD from the contact relay 22R through the coils of the relay 22 HDR from the contact relay 22 TR with the wire 22 HD from the contact relay 11 TR with the black contacts so relays 11 SR 11 and 12 HPR with the negative battery CS with the current flowing through the coils of the relay 22 HR in this direction will cause the right hand polar contact of the relay to be closed thereby completing the circuit displaying the approach aspect, receiving the positive battery from the through the contact relay 22 HPR, right hand polar contact relay 22 HDR wire 22 HG yellow and approaching unit with a wire EN from the back contact relay 21 HPR with the negative battery C with the rear of the train passing signal 2 relay 12 HDR will energize and relay 12 SR de-energized. Then you can't read the rest of that because it's clipped off the top of the page. But moving on to traffic control system. The traffic control system is a block signal system under the train movement authorized with the block system who indicates the supersede with the superior over the trains with both opposing following movements on the same track. Alright, in the traffic control system standard code, the rules 261, 263, and 264, which the govern the opposing following movements of the train, the block signal on the same track are in effect. Traffic locking must provide with a part of the traffic control system prevent the manipulation of the lever over the device changing the direction traffic section of the track while the section is occupied while the signal displays an aspect movement to proceed in this section. Where Rule 261 is a fact provided with the trains governed by the block signal indicates the supersede of the superiority train can certain requirements in addition to those required with the absolute block signal must be met as follows. 1. Signals governing the movement of the higher and then restricted shall be controlled with the continuous track circuits. Also, additional error at the control point there shall be controlled with the control operative manually operated, interlocking manually in cooperation with the control operator. 2 signals at this control point shall be interconnected aspects proceeding cannot be displayed simultaneously conflicting movements. 3 signals in adjacent control points shall be interconnected through the aspects proceeding cannot be displayed simultaneously conflicting movements. 4 on-track signal movements in both directions. Occupancy of the track must be between opposing signals. Adjacent control points shall prevent the changing of the direction of the traffic from which the obtained at the time of the track can became occupied. 5. Occupancy of the track circuit control shall be automatically indicated by the control station. 6. Approaching the time shall be provided with all control signals of the electrical locks and hand-operated switches. 7. Each hand operated which installed with the main track where the train movements are made with exceeding 20 miles per hour shall electrically lock in normal position. Electrical lock may be unlocked in either automatically or by control operator, but only after the control circuits and signal governing movements over the switch at each end of the direction have been opened. In territory listing the timetable special instructions rule, where Rule 261 is in effect, the singles interlocking block station is operated with the manually controlled the track circuits and other electrical mechanical agencies subject to the rules in effect. Where operator is located in the adjacent block station, and there must be communication with each of the other and obtain use of the block in addition with the most cooperative with each other, meaning the operated lever device in one block station releasing lever device in the other block station permits this. Traffic conditions determined with the manual block automatic block system rules shall be in effect in the following trains. Online light traffic where considerable desire to be operated with the Rule 261 intermediate automatic signals may be omitted, but the manual block system rules may be applied with the following movements so that the operation would be similar to the manual block except that the trains would operate with the signal indication which would supersede the timetable superiority dispensing train orders. On lines denser, the automatic block system rules will be placed in effect immediately. Automatic block signal systems in both directions would be installed using arrangement. Trains would continue operating the signal indication which would supersede timetable superiority dispensing with the use of the trains, but the train movement in the same direction would be governed by the intermediate signal, similar to the extent of the early part of this chapter. There are many different ways of circuits and devices using the traffic locking so that it would not practically enumerate this chapter, but Figure 16 illustrates a typical traffic circuit between two attended offices. The principal operation similar to the other types of the circuit, but the main purpose is to ensure all opposing signals are locked out before clearing the signal governing the movements to the track question. In certain causes, all signals are controlled with the same block station traffic locking combined with one machine. Figure 16 shows the two-wire traffic control arrangement. The signals are drawn show the traffic direction establishment, eastward movement with the traffic established with the westward movement. Both traffic levers are in reverse position. Lights are provided with the show the block occupancy direction established. A bell is provided to indicate the adjacent office desire to change the established traffic. Blocking Rectifiers are shown in the control of the FR relays to prevent discharge of one battery into the other in case of unequal potential. The reverse traffic direction, the east of the office pushes the traffic button 1 PB will energize the relay 1 PB. Reverts the energy to the relay 27 NFR, de-energize the relay 27 KFR, which receive the energy, and the normal polar contact relay 27 NFR. When the relays of 27 KFR de-energize, energize, and operating the 1 PB, the bell will ring, the block light will flash, and the west office reverses the traffic lever 27 de-energize the relay 27 NSF and NFSR, placing the traffic batteries in opposition releasing relay 1 FR. With the relay 1 FR is de-energized, the relay 1 KFR is de-energized. The bell at the east of the office rings. The block lights are extinguished. Each of the office of the reverse traffic lever is 1, which are energized. Realize the RFR relay 1 KFR energized with the contact of the relays 1 RFS. 1 RFSR, 1 RFR, the lights and block lights and removed energy from the bell. The relay 1 FRPR is now energized from the contact relays 1 FR and 1 RFSR will relay 1 FRPR energized. And then it blocks out, like, they cut the pages. Whoever scanned this scanned it wrong. Intermediate signals are frequently provided with a controlling station permitted the following movements under automatic block signal system, but these signal controls are not shown as they are similar to these previous figures in the chapter whatever modifications may be necessary. Alright, and Figure 11 shows the circuit of two black indication normal clear color light signals, two tracks, one black overlapping alternating current tracks, circuits and direct current neutral line contactors. Very complicated shit. Figure 9 shows a circuit for four aspect searchlight automatic block signals. Figure 8 shows circuits from two black indication normal clear color light signals, two tracks, alternating current track, and control circuits. Figure 7 shows circuits for three aspect searchlights, automatic block signals. Figure 5 shows circuits of three aspect color lights, automatic block signals. Figure 5 shows three aspect color light, automatic block signals. Figure 6 shows circuits using relay cut sections, neutral line relay. Figure 16 shows relay type traffic circuits between attended offices. And that completes Principles, Practices, Chapter Block Signal System, Chapter 15. Thanks for listening.